Hey guys, Mr. B here with some more of your DBA review. Sorry last night I did not get out a video, so I'm doing 2 days worth today. I left off on question 24, so I'm going to pick up today on question 25. This is a thinking question. It really does make you think about what's going on, but it's very simple. And let me see if I can simplify it for you a little bit. It says the shaded model represents 100%. So this piece is 100%. Which one of these models below represents 33 and 1/3%? And I'm just reminding you that 1/3 is equal to 0.3. All of my students should have that memorized. It's a repeating decimal. So 33 1/3 would be 33.3 repeating. And you don't have 33 1/3, you have 33 1/3%. All percents are out of 100, so you could think of that as 33.3 repeating out of 100. And so if you want to figure out which model represents 33.3 repeating over 100, then think of it, instead of as a fraction, think of all fractions are division problems. So 33 3/10 repeating over 100 is 33 3/10 repeating divided by 100. And if you divide any decimal by 100, that's the same thing as moving the decimal place 2 places to the left. So if you take 33.3 repeating and move that decimal 2 places to the left, that's the same thing as dividing by 100. When you do that, you're left with 0.333 repeating. And so you're looking for a picture that shows 0.3 repeating. Well, there's only one picture that has something equal to that, because when you look at this, this is 1 out of 3. And again, 1/3 is 0.3 repeating. So you really have to have 1/3 memorized as a decimal, and you should. We worked on this a lot this year. This one is 3/10, so that's going to be 0.3 and then stop. That is not 0.3 repeating, it's just 0.3. This one here is 1 hole, 2 holes, 3 holes, and 1/3. So this is not 33 and 1/3, this is just 3 and 1/3. And this one here is 3 holes and then 3/10. So this is 3.3, not 3.3 repeating. So it's a very fine line between right and wrong on this question, but hopefully you can pause this video and kind of talk about it and look at that to make sense of it. All right, 26, the table shows the relationship between the perimeter and the area of the squares. So you got a relationship between A and P here, and wants to know which equation can be used to find A, the area of a square that has a perimeter of P. So you really just need to choose some values from this table and plug them into these equations. So instead of using A or P, you would want to use 1 for A and 4 for P. Or you could use any of these other values, but it's a lot easier to use 1 and 4 than it is to use these other numbers. So you can see what I did here. I just said, all right, instead of A, it's 1, and instead of P, it's 4. So wherever there was supposed to be an A, I put a 1, and whenever there was supposed to be a P, I put a 4. So 1 is equal to 4 divided by 4 times 4 divided by 4. That's true, because 4 divided by 4 is 1, and 4 divided by 4 is 1, and 1 times 1 is 1. So that makes that true. If you try that for H, and I'll tell you why I'm skipping to H in a minute, but if you try that for H, if you put a 1 in for A and a 4 in for P, you're going to get, you're doing addition, so 4 plus 4 is 8, 4 plus 4 is 8, and 8 times 8 is 64, so that doesn't work. I didn't work the other ones out because you can easily see, if I put a 1 here, 1 is not going to be equal to 4 minus 4, because 4 minus 4 is 0, and 0 is not equal to 1, so G can be ruled out easily. And there's no way this could be correct. A is not equal to P, because 1 is not equal to 4, and 4 is not equal to 8, and 9 is not equal to 12, and so on. So this was the silly answer out of all of those. All right, so that was number 26. Here's 27. We've been working on dot plots in class. We haven't seen any that have X's in them, so this looks new, but that's the same thing as a dot. We have not learned stem and leaf plots, so this is going to be a confusing question until you watch this video. But anyway, it wants to know which one of these matches this data. Well, first of all, take the data, fill in the blanks on the dot plot so you know what the missing values are, and then just make a list of it. So you've got two 18s, you can see by the two X's. You have, this one's in between, so you have a 19, you have a 20, a 22, a 26, you have three 31s. I marked, yeah, here's 30 and here's 32, so that's between, so that's three 31s. And then you have a 34, so make yourself a list first. Now, the way a stem and leaf plot works is the tens place value goes on the left and the ones place value goes on the right. So when you see a 1 here and an 8 here, that's like saying 10 plus 8 is 18, 10 plus 8 is 18. So tens place value, ones place value. So this would be 18, 18, which we do have two 18s. And then it skips 19 and goes 20, 20, 22, 26. So that's not right because it left out the 19. This one works. You can see we have 18, 18, 19, 20, 22, 26, 31, 31, 31, 34. So that has all of the values that we're looking for in the list. And you can check and see the other ones don't. This one's 17, 17, 18, and there's no 17s. So that's why that one's wrong. And this one's only showing one 18, and we have two of them. So that's how a stem and leaf plot works. It uses place value. All right, number 28 here. A meteorologist at a television station reported that a town received 0.95 inches of rain. Which fraction is equivalent to this amount? So 0.95 is 95 hundredths. So place value, again, 95 over 100 is the fraction that equals that decimal. I noticed they're both divisible by 5 because they both end in 0 or 5. So I divided them both by 5. And I got 95 divided by 5 is 19, 100 divided by 5 is 20. I just did this over here to check it. And then I checked it one more time by taking my answer of 19 over 20 and multiplying them both by 5 to get back to 95 over 100 just to check and make sure that it works. So this one here is an equivalent fraction to this fraction, which is equivalent to that decimal. All right, number 29. The table shows the average annual salary of 4 jobs. You may not know this yet, but annual means 1 year. So this annual salary, that's how much a copywriter makes in 1 year. A librarian makes this in 1 year. So this is a whole year's worth of salary. So average annual salary. So based on this information, how much more will an elevator technician make than a librarian in 10 years? So if you know how much they make in 1 year, you got to multiply it by 10 to see how much they make in 10 years. So elevator technician made 71,900. You multiply that by 10, you get 719,000. You multiply the librarian's annual salary by 10, and you get 54. Oh, a comma. Nope, it's in the right place. 544,070. And then it said how much more. So you're comparing them. So you got to subtract them to see how much more. So that technician is going to make $174,930 more than the librarian. Pretty easy question, I think. All right, 30. A teacher wrote this expression. What's the value of it? So parentheses next to parentheses is multiplication. So -6 times +2 plus -8 divided by +4. So it's multiple operations, so you need PEMDAS. So no exponents, no parentheses. There are parentheses, but these really aren't grouping parentheses, they're multiplication parentheses. So if we do the parentheses first, you've got a negative divided by a positive, which is going to be a negative. So 8 divided by 4 is 2, but this is negative 8, so it's negative 2. And then if you multiply a negative times a positive, you get a negative answer. So you've got negative 12 plus 2, and when you add two negatives, it's just it's already negative. You're adding more negatives, so it's still going to be negative. So a negative plus a negative is a negative. So it's kind of like we talked about in class. You got 12 bad guys, you add 2 more bad guys, and you got a total of 14 bad guys. So number 31, which equation has a solution of 2/3 for n? It's asking you in which one of these is n 2/3. There's not an easy way to do this. You just have to take n and trade it for 2/3. So that's what I did. So instead of writing n minus 1 equals 1/3, I did 2/3 minus 1 equals 1/3. So you can see where I worked it out here. 1 is just 1 over 1. You can't subtract or add fractions unless you have common denominators. So I had to change 1 over 1 into 3 over 3 to get the denominators the same. And 2 minus 3 is negative 1. So I ended up with negative 1/3, not positive 1/3. So A is not right. And B, I traded out, again, I traded out n, 16 times n. So I traded it for 2/3. So 16 times 2/3 equals 24. That's just 16 over 1 times 2/3 equals 24. 16 times 2 is 32. 1 times 3 is 3. And 32 divided by 3, 3 goes into 32 10 times with 2 left over. So this is equal to 10 and 2/3, not 24. So that doesn't work. And then I found the answer on number 3. 15 times n equals 10. So 15 times 2/3 equals 10. And you multiply straight across and you get 30 over 3. That's 30 divided by 3, and 30 divided by 3 is 10, and 10 does equal 10. And then there's the last one, just to check and make sure. 1 and 1/3 plus n, so I traded it again. 1 and 1/3 plus 2/3. 1 and 1/3 is the same thing as 4/3. 3 times 1 is 3, plus 1 is 4 over the same denominator. So you can add these now because they have the same denominator. So 4 plus 2 is 6. 3 plus 3, oh, we don't add the denominator, sorry. Keep the same denominator. 6 divided by 3 is 2, and 2 does not equal 3. So no easy way to do that type of question. You just have to plug in the value and see which one makes it true. All right. Number 32, it's been a while since we've done this. This is all the way back from the first and second week of school, talking about whole numbers, integers, and rational numbers, okay? So remember how a nesting box works. This is a category inside of a category inside of a category. So if you call this a whole number, you're saying, if you say 3 is a whole number, you're saying it's also an integer, because that box is in this box. And if it's also an integer, it's also a rational number because that box is in this box. So if you place it in the middle, it's all 3. If you place it in the second box, it's just these 2. And if you place it in the outside box, it's only that. So 3.4 is a decimal, so it is only a rational number. It can't be anything else. You can write it as a fraction or as a decimal. So that's what rational numbers are. So it's only a rational number. Negative 2 is an integer because it's negative, but it can also be written as a fraction or a decimal. So it's also a rational number. So negative 2 belongs in the integer box, which is inside of the rational number box. So negative 2 is this category and this category. 3 is a whole number. Whole numbers belong to all 3 because that can be 3 or 3 over 1 or 3.0. So that's in the right spot. Negative 1.2 is, sorry, you're getting to listen to my dogs bark there, but negative 1.2, it's not, don't think that just because it's negative, it's an integer only. It's still a decimal, so it's a rational number, and it can only be a rational number. It's not, integers never have decimals that go with them, so just think back to when we talked about this and try to find which categories they go in. Remember what it takes to be a rational number, fractions and decimals, what it takes to be an integer, and what it takes to be a whole number. And that should help you remember your categories that they go in. All right. Number 33, a lot of reading involved in a question like this. You just have to read. It says, which situation cannot be represented by the equation x plus 10 equals 45? So it's just saying something plus 10 equals 45. So we're going to read 3 situations that can use this and one that can't. So here we go. Marissa spent $45 on a hat and a shirt. Okay, so she spent a total of $45. It says the hat was 10, and it says what is X, the cost of the shirt. So here's your hat and here's your shirt, and together she spent $45. So that represents what's going on there. That works. Nicholas rode his bike for 45 miles last week. There's his total. He rode 10 miles on Tuesday and the rest on Wednesday. So here's Tuesday, here's Wednesday, there's his total. That works. 2 players scored a total of 45 points in a game. 1 player scored 10 points. What is X, the number of points scored by the other player? So total of 45. Here's one of the player's points. Here's the other player's points. That all works, but it's this last one that doesn't make sense. 45 students in a group. There are also 10 adults in a group. What is X, the total number of students and adults? So it's saying students plus adults. Well, that's 45 plus 10 based on this story, which is a total of 55, not 45. So it was pretty easy to find the one that didn't match. All right, the dot plot shows the number of chess games won by each of the 20 students in a competition. We worked on this just last week. Here's a dot plot. It's asking about medians and interquartile range. We know how to do that because we just did this on Thursday and Friday. So I took all my dots and made my list. So here's my list from least to greatest. Counted up all of my numbers, and there was 2 middles, 4 and 4. So the median is 4, right between them. That's, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in the second half, 10 numbers in the first half, so you split it right down the middle. Quartile 1 is just the middle of the first half, so you got 1, 2, 3, 4, 5 numbers on this side, 1, 2, 3, 4, 5 numbers on this side. So halfway between 1 and 3 is 2, so quartile 1 is 2. 5 and 5 splitting the second half, halfway between 7 and 7 is just 7. So now you have your quartile 1 and your quartile 3, and the way you find interquartile range is just subtracting Q3 and Q2. So 7 minus 2 is 5. So your IQR is 5, and your median is 4, and answer choice G is the only one that matches that information. So that should be fresh in your mind. We just did this on Thursday and Friday. We practiced it a lot, so you should be able to do a question like that. All right, 35, fraction question. The shaded area on the grid represents the part of the rectangular wall that was painted. Each small square has the same dimensions. What percent of the wall was painted? So now what fraction was painted, what percent? So when I counted up all the shaded sections, there was 24. There was a total of 40, so it was 24 out of 40, but percents are out of 100, not out of 40. So I needed to get it to a denominator of 100. So the way I did that was I got the denominator to 20 by dividing it by 2. So I had to divide 24 by 2 also, so that's equal to 12 over 50. And then 20 times 5 is 100, so I multiply 12 times 5, which is 60, and 60 out of 100 is 60%. You could also just divide your 24 out of 40. 24 over 40 is 24 divided by 40, so you could just divide it. And 40 goes into, it doesn't go into 24, so it's going to be a decimal. And 40 goes into 246 times exactly. And so 0.6 is what you're dealing with there. That's 6/10. 10 times 10 is 100. 6 times 10 is 60. So there's another way to get your 60%. or you should just know 0.6 is equal to 0.60, which is 60 out of 100, which is another way to get your 60%. So, and I think this is another easy question that we should not miss. Let's take a look at 36. New material I haven't taught yet. This is the personal financial literacy unit, but I still think you should be able to do this. Before Nina bought groceries on April 22nd, she had a balance of $487.25 in her checking account. Nina wrote transactions in her check register. She included all her transactions through the end of the day on April 23rd. What you need to know is that deposits are money you put in. So that means you add money to your account when you have a deposit. And withdrawals are money that you take out. So like when you pay for something, you lose that money, so you take it out. And then a balance is just how much you have. So she had $487.25. She spent $72.50, so we took that out. So that's what was left, $414.75. And then a day later, she added 15. So there's me adding the 15, and there's her new balance after all that was done. So $429.75. All right, which table shows only the values that represent the following relationship between Q and R? Well, the relationship is R equals Q plus 10.1. Or you could flip it around and say, Q plus 10.1 equals R. So just go take Q and add 10.1 to it and see if you get that value. If Q is 5 plus 10.1 is 15.1, not 50.5. So that doesn't work. Same thing, 5 is Q. 5 plus 10.1 is 15.1, not 10.6. So that doesn't work. But it works for all of these values. 5 plus 10.1 is 15.1. 7 plus 10.1 is 17.1. 9 plus 10.1 is 19.1, and 11 plus 10.1 is 21.1. So it works for all these values there. It works for this first one, but it doesn't work for these others in answer choice D. So answer choice B is the only one where it works for all of them. All right, a couple more here, and then we'll be done for today. Hard question, but doable if you use common sense. A recipe for cookies requires 2/3 cups of butter. Rama wants to make 3/4 of the recipe. How many cups of butter should Rama use to make the recipe? All right, so if one whole recipe uses 2/3 cups of butter, and she's making less than one whole recipe, then she's going to need less than 2/3 cup of butter because she's making a smaller recipe than one whole. So what that says is you're making less than one recipe, you're going to use less than 2/3 cup of butter. Well, this is over 1. This is 1 and 5/12. So that's more than 1, which is definitely 2/3 didn't get smaller, it got bigger. So that doesn't make any sense. 2/3 itself, you should have memorized, is 0.6 repeating. So if you needed 0.6 cups of butter for one whole recipe, then you're going to need less than 0.6 cups of butter for a smaller amount of the recipe. So 8/9 is over half. 4.5 out of 9 is half, and you have 8 out of 9, so this is, again, too much. 1/12 is a very tiny amount. 1/2 is exactly half, so these two at least are half or less than half, so H and J makes sense. These two are over half or over 1. But if you just think about this as what you're doing is you're making 3/4 of a recipe. You needed all 2/3 when you made a whole recipe. So now we don't need all of the 2/3 for one recipe. We need 3/4 of 2/3. And we talked about this all year long. Of means multiply. So 3/4 of 2/3 is 3/4 times 2/3, which is equal to 6/12. 3 times 2 is 6, 4 times 3 is 12. That's equal to half, 0.5. So there's the half of the stick of butter or the cup of butter that you're going to need. All right, number 39. A robot's height is 1 meter 120 centimeters. How tall is the robot in millimeters? Use your formula chart. 1 meter has 1,000 millimeters in it because 1 meter has 100 centimeters in it. And then there's 10 millimeters inside of every centimeter. So if you've got 1 meter that has 1,000 millimeters in it, and then you also have 20 centimeters, so there's 20 centimeters, but there's 10 in each of those, so 20 times 10 is 200, so you get 200 millimeters out of your 20 centimeters, and you get 1,000 millimeters out of your meter. So together that's 1,200 millimeters. Use your formula chart to make those conversions. You're not probably going to have it memorized, so you got to use that chart. All right, number 40. It's going to be the last one for today. Aiden asked a group of students to choose their favorite type of music from the choices of rock, hip hop, and country. So he talked to 20 plus 40 plus 30, so that's 60. 60 plus 30 is 90. He talked to 90 people. 20 said rock, 40 said hip hop, 30 said country. Based on the graph, how many students in a class of 360 students would be expected to choose rock or hip hop? So what it's saying is his class was a class of 90, and rock and hip hop was 20 and 40. So total, that's 60 out of 90 chose that. Okay, 60 out of 90 chose that. But they're saying what would be expected if 60 is expected out of 90, how much would be expected out of 360 total students? And so you just set up a ratio. So if 60 out of 90 choose that, and I want to keep that ratio intact, I'm going to add 60 more and 90 more. So now I have a total of 180 students. That means out of 180 students, 120 would pick rock and hip hop. So if I add 60 more, and I add 90 more. So if I had 270 total students, 180 would pick rock and hip hop if we based it off of this same ratio. And then, so again, add 60 more, 90 more. And that's how I landed on 360. So if I had 360 students instead of 90, I would expect 240 of them to pick rock and hip hop if we use the 60 to 90 ratio. I also kind of set it up in a table to kind of get the same effect there. So, 60 more, 60 more, 60 more, 90 more, 90 more, 90 more. You can think of it as, this right here, 60 and 90 both times 2, and then 60 and 90 both times 3, and then 60 and 90 both times 4. So just keep the ratio intact, and it'll help you find what you need. So that's all I got. I know this is a long video. It's just going to be barely under 29 minutes, but pause it when you need to. Go back and study. Hope you're studying this weekend. The DBA is going to come fast on Wednesday, so I need you guys to be ready. Thanks for watching, and I'll see you at school on Monday.